All right, thinking about our layers of the earth for another section of our Tectonics Explain. As always, we've got the notes on the left, a couple diagrams, and questions on the right to answer as we go. So make sure you are following along with me. Here we just have a super cool image of the earth without water, which is just a good reminder that the entire outer part of the earth is the crust, right? We can see different pieces of land, we can see different pieces of the ocean underneath the water. And so just a good reminder that the entire outer part of the earth is that main layer that we've investigated so far, the earth's crust, right? We know that there's several layers and lots of different ways we can think about it, but just three big ones compositionally. We, of course, have our crust. That has been our focus so far. We've got then the mantle, that thicker piece, followed by the most interior layer, which is the core. So crust, mantle, core, nothing new there, but we want to make sure we break down and know the characteristics of those layers. And so we're thinking about today, how do those characters move? What kind of temperature patterns are we seeing within those layers? And as, again, density as well. So those are the characteristics we are focusing on today. Location, real quick with the diagram here, movement, temperature, and density. So we're jumping over to the right-hand side right away to do a quick label on this diagram, little pie piece of the earth. We, of course, are looking at the core down here at the bottom, the most interior part of the earth. A lot of you mentioned to me earlier in the week, we know we have the inner core and the outer core. For our purposes here, we're really just thinking about the core as a whole. So you can go ahead and get that guy labeled down here. Now the mantle, we can see, is also broken up partially into these two sections. We'll start to investigate those today in terms of, like we said, temperature, density, and motion. That is our mantle. And then the tippy top, again, has multiple parts, but we're thinking about them together today as one, that as the outer layer of the crust. This light blue right here is really the atmosphere, just kind of pulling it all together. So the ocean crust is underneath the water, and then of course the land we can see is our continental crust. So stay tuned with that diagram. We'll keep adding a few things on it as we go. So a few details and reminders about the crust. It is, of course, the outer layer. It is very brittle. Brittle is a fancy way to say that it breaks easily. If you need an extra reminder there. So any kind of pressure or movement of that thin outer layer, we see those cracks, those breaks, those faults that we've been talking about in our geologic history unit. Like we said, it's really thin and it is the most outer layer. So in terms of density, it has the lowest density of all the layers on Earth. And it is also the coolest temperature. Right? If we think about the atmosphere being its general temperature of like 0 to 100, that is the temperature that those rocks are exposed to on the daily. So on the right hand side would be a great idea just to remind yourself up here at the top, the crust, we're thinking about low density and also cool temps for our crustal layer. And like we mentioned, it is broken down into two pieces, oceanic and continental crust. So when we refer to continents, we're really talking about the land, and the ocean is, of course, underneath the water, that rock that we can't see with our eyes, but we know that it's there. So of the activities we've done so far, obviously the crust is the example of the shell from our egg, right? It has those thin, brittle characteristics. With any kind of pressure, we see that breakage happening super easy. And our Earth's crust is the same in that way. Now the mantle is one of our thicker layers of the Earth. It's directly below the crust. Like the crust, the mantle is also solid. But we can't use those same characteristics of rigid and brittle and cool when we think about the mantle. Even though it has that same characteristic of being solid, it's a very different layer. It is a little bit more dense than the crust. It's underneath, so the crust essentially floats above the mantle. And it's obviously a little bit warmer. We know as we go down towards the earth, we're increasing in our heat. So we're seeing that mantle temperature kind of average out around 3,500 degrees Celsius. So more dense than the crust, and of course warmer than the crust. Like we said, despite those small changes of warmer and more dense, it is still considered to be a solid. Now we can see here in our picture that we have, that mantle is broken up into multiple pieces, just like we talked about the crust and the core being multiple pieces. So we do need to get to know those individual parts of the mantle a little bit more, because they really add to our evidence that we want to think about. So the layers of the mantle, we've got two. Now the upper mantle section have kind of similar characteristics to the crust because they're attached to it. This upper layer does have a brittle and rigid characteristic similar to the shell. We know that section of the mantle known as the lithosphere. And if you look on your original picture, I kept that lithosphere labeled there. It's sitting right underneath that continental crust, and you can see it even a little more so here on this zoomed in picture. That lithosphere is essentially attached to the crust, both continental and oceanic. So this lithosphere would be a good word to star, circle, highlight, underline, do something so you can kind of get back to that definition and these details really easily. This lithosphere, like we said, is connected to the crust. It's directly underneath. The second layer of the mantle, the lower mantle, again, still solid, but because they have that heat characteristic, that superheated solid is described as plastic-like. And we're not talking about plastic-like in terms of like a water bottle, but we're saying plastic-like because it's able to flow a little bit. Okay, kind of think about it like a silly putty or like a toothpaste, right? Toothpaste comes out of the tube as a solid, but if you build a little toothpaste pile or tower, if you will, on your bathroom counter in the morning, you get home and there's going to be some movement to it, some flow, because gravity is acting on it. So this layer is known as the asthenosphere. And that would be another good word to highlight, star, circle, underline, do something so you can always get back to that quick description of the lower mantle being known as the asthenosphere and described as plastic, having flow because of its warmer temperatures. And I also kept that labeled on your diagram right here, asthenosphere. So that would be a good thing to view in there. So just to get kind of an idea of what that might look like, you know, we can't see into the earth, but this is a great view and representation on how we think that movement is happening, right? And you can see with that asthenosphere movement, that kind of like pillowy cloud part, it's really pulling that crust along with it. And that's an idea we're going to keep circling back to. So this diagram zooms in a little bit more, allowing us to see really where that asthenosphere and lithosphere are at. Remember, those together are the mantle. So we have a little request here to label characteristic of the layers. We want to put the description of plastic-like into our asthenosphere layer here. So this is our plastic-like layer. Or meaning it has a flow to it. And again, that's happening because of the heat that that layer has. Oh, I put that in the wrong spot. We want that on our asthenosphere, sorry. This is our plastic or flowing layer because of its heat. And our lithosphere then is that more rigid, brittle layer. It's not as hot, not as close to the heat of the Earth's interior, so it's a little bit cooler, more similar to the crust. Remember, it's linked to that crust up here at the top. So we've got that question on the right-hand side that we want to answer right here. The question says, how is a boat floating on the ocean similar to the relationship that we're seeing here with the lithosphere and asthenosphere? So discuss density and motion. So the idea here is the boat on the ocean acts a lot like our lithosphere and our asthenosphere. So when we think about density, more dense versus less dense, we know more dense objects sink downwards. So that means our asthenosphere and essentially our ocean, well, those would be more dense, right? They're heavier because they're on the bottom, while the lithosphere and the boat are floating. So those are our less dense objects. So when we go to describe it, we're thinking about the lithosphere being less dense because it's floating on the asthenosphere, sitting on top. And then in terms of motion, well, we know if the ocean current is moving a certain direction, well, that boat is going to move the same way. And we see that same pattern happening with the asthenosphere. If the asthenosphere is moving in a certain direction, the less dense lithosphere floating on top is also going to move in that same direction. So take a little pause real quick and make sure to get those details in, right? Like we said, we know the lithosphere is less dense, so it's floating on top, and any motion of the asthenosphere drags the lithosphere along with it. And if I can, I'm just going to circle back to that little video. Went too far. So we can kind of get that visual again, right? Here's our asthenosphere moving. If you look closely, you can see that crust moving as well, being dragged along with it. The direction that asthenosphere moves, well, the crust moves the same way. So take some time and get some details in on the right. I'm going to be looking for those ideas of density and motion. So circle back if you want to hear that description again. Our final layer here is the core. Again, I know you've thought about the core being the most dense. It's the heaviest. It's sunk all the way down to the bottom, the interior of the earth. In your diagram, that would be a great thing just to label real quick at the top again. This is the more dense part of the earth, or we could even say most dense. Again, circling back to our hard-boiled egg demonstration, this is thinking about the yolk, that yellow part, being the most dense and all the way at the center. Now we also know it's the hottest part of the earth, and this is kind of cool thinking about where that heat is coming from. But that core is superheated by a lot of the friction or the movement of those materials inside. Remember, gravity's pulling those materials down all the time. Those are all little teeny tiny particles, and as they get pulled down by gravity, they're moving. They're kind of swirling around inside the earth, and just that friction of them bumping into each other causes heat. They're also decomposing, and that's tricky to think about an atom doing that, but what's happening is they're shedding parts of their atomic structure and becoming a little bit unstable. So they end up being radioactive. and releasing heat from that as well. So from the friction of motion kind of settling due to gravity, even though the Earth is so old, gravity's still acting on those interior pieces, and all those particles becoming unstable as they age also adds to the heat. So this is a big idea we're going to keep circling back to. So I would star, circle, highlight, underline that idea of where that heat comes from. I know you know it's hot already on the inside, but we want to make sure where that heat source is coming from. And the main elements that we have there are those higher and heavier elements. Hopefully this element rings a bell from our stars unit, thinking about it being more dense with all those higher elements, higher weight elements. So we're wrapping up here with one final prediction. How does the heat generated by the core impact the rest of the layers? So the rest of the layers being the mantle and the crust. What do you think the impact of the heat is there with the rest of the layers? Just predict an idea, just can't leave it empty. Okay, so you got all the notes on the left side, you labeled our diagrams, you answered our 2 questions happening over here. That means you're ready to roll into learning target number 2. So looking at our green study guide, learning target number 2 is broken up into 2 parts. Diagram 1 should look pretty familiar. Label up just like we did in our notes here. A few different things to label in terms of temperature, and a describe having to do with density. So as you are answering your density question, those 3 words should be sprinkled in. You're using the question to set up your answer. So remember, level of density as I move from the crust to the core would be, you already got your 2 words in there. Then tell me about where it's most dense and where it's least dense, and pop those names in as you go, right? So make sure you highlight them in your description. And again, go side by side with your notes, right? This should look really familiar at this point. Second part of learning target 2 is down here with diagram 2. You see here we've got the labels of the parts we just focused on, lithosphere and asthenosphere. So we're adding in 2 characteristics of each one. Again, we broke those down in our notes. And what do we know about the movement of asthenosphere impacting the lithosphere? This was like our boat question, right? So again, we're thinking about using and highlighting all these words in our learning target number 2. So those should all be used and then highlighted up. So I'm going to be looking for those uses and highlights the next time we are together. As always, message me any questions or clarifications that you might need.